Hello everyone, it's April 15th. Alright, back to our grind. So what we're gonna do first, trim a binary tree, and then let's pick another medium question. Alright, trim a binary tree. 669. Oh, that might be. Oh, I've solved this before. Alright, so what do we do? Trim. Given the root of a binary tree and the lowest and highest boundaries. Hold on. Binary search tree. That's low and high. Trim the tree so that all its elements lies in low and high. Trimming the tree should not change the relative structure of the elements that remain in the tree. Any node descendant should remain descendant. It can be proven that there is a unique answer. Return the root of the trimmed tree. Okay, so we want 1 to 2. Okay, we want 1 to 3. 1 to 3, which means 4 is gone. Oh, 0 is gone too. Okay. The value is unique. Root is guaranteed to be a valid binary search tree. Okay, so we have a range, right? So for each node, we're gonna check, right? If the node is inside the range, it will be kept. If it's not in the range, then we end, right? So in this case, we do 1 and 2. So 1 is inside the range. So this one will be kept. And then we're gonna check. We can actually check for not check for. We just immediately go to the left and go to the right. And in here, 0 is outside the range, so we need to return none. Okay, so none. And this is inside the range, so we keep going. Left is none, then we return none, right, none. So this one is done. Okay, so this one was 1 to 3. Okay, 1 to 3. This is good. We set here and here, and then here. 1 to 3. It's outside. Oh, we cannot return immediately. We shall return. So it's outside. This one is outside, right? So this one is too small. Therefore, we don't have to go left, so we return the right. Right? Return right. And this one, 4, is too big, so we shall actually return the left. Right? Because the left, we might have something smaller. So in this case, okay, let's try that. Soy viajero. Alright, so what do we do? Low and high, right? So we're going to check. We say, okay, if not root, I will return none, no problem. If I have root, now we say, if low smaller equal to root dot val smaller equal to high. So root val is inside, and then we just say root dot left equals self dot trim root dot left low and high, and then root dot right equals self dot trim this root dot right low and high, right? Okay, and then elif root dot val is smaller than low. Okay, so root dot val, right? Root dot val is smaller, smaller. So root dot left shall be none, and root dot right. Doesn't really matter. I think I can just keep doing this, right? And eventually, but I can terminate it earlier. Wait, hold on. Let me think it through. So I'll always do the left. What if it's smaller and I do left? and the left says we're going to trim, and it has something, and then we just keep going left. So it's left will be none, and then return this. Nah, I think this is right. So then the right will do the same thing. I think I should be doing this. Let's say if root dot val is smaller than low, then root dot left is none, right? If root dot val larger than high, then root dot right is none. Otherwise, nope. Because in this case, I still need to check root dot right, and this has to check root dot left. You know what? Let's just do it the right way. Right, and then we can say else, do this, and then return root. Don't bother, we're not going to do this. Let's try this. Oh my god, terrible. What the heck? I'm not deleting anything. Hold on. What happened? So, okay, and then we're gonna do this left. So we do left is this, right? And then if this is smaller than low, oh, we shall return. We shall return this, right? Yeah, we shall return this. If it is, then we shall return the left. And then else, then we do this. Okay, try this one. This one's right. Edge case. What is the edge case? Edge case, let's say we put one value, and then we put, I don't know, 1 to 11, and then same thing, say 1 to 3. Okay, all right, try this. Pretty good. All right, let's see my solution last time. This one is 690 something, 669. Straightforward, right? Straightforward solution. If the root value is outside the range, we can choose. We only need to outside the range. We definitely discard the root and the branch where the value is going to be even more outside the range. We return the branch that might have some value within the range. Right. If the root value is inside the range, we must keep it, and thus we have to check both its branches. What's the runtime on this? Well, worst case scenario is ON, so let's call it ON. Okay, so this is the last time my solution. It's the same thing. Oh, root vowel minus 1. Yeah, I guess it's fine. Okay. So we're done. Let's see. Do we see a solution for this? Recursion. That should be only one. Yeah, only one solution. Not node, larger, return left, smaller, return right, else, blah, blah. Yeah, it's the same thing. Okay, so let's call it done and move on to the interesting one. 2 keys keyboard. There is only one character on the screen of a notepad. You can perform one of 2 operations on this notepad for each step. Copy or. You can copy all characters. Given an integer n, return the minimum number of operations to get the characters A exactly n times. So I have only one letter. Interesting problem. Holy guacamole, yeah, 3. We have 1, so we either copy it and then we paste. So the worst case is n, right? But we want to make it better. So we use copy, we paste to get, and then we paste. Well, remember, every time you paste, you're adding the last time you copied. Holy guacamole. What's the idea? Well, I mean, the best we can do is, we start with 1, right? We can do 2, 4, 8. So it can double, right? So if the n is power of 2, right? If n is power of 2, then it's just going to be the log of 2, right? Let's say if it's 4, right, then we need 1 operation to copy. Oh, hold on. We need to copy, and then we need to paste. It becomes 2, and then copy. Hold on, so we have 1. So copy, paste, copy, paste over 4, right? And then if so we actually did it. So I do think these are the keys to this problem. The 2's, the power of 2. So let's say 4, 8, 16, and 32, right? So my expectation is for 4, we need 4 steps. For 8, so I'm going to copy again and then paste again. Now it becomes 8. So it's 1, 2, 3, 4, 5, 6. So 6 step. And then 16 will be 8 step. 32 will be 10 step. So that was my idea. 4, 6, 8, 10. Yeah, exactly. So the key is definitely to utilize this copy and paste, and it can achieve better results. But then, if it's not, right? If it's not, can we like say, oh, it will be hard, like 3, 2. We can say 2, right? 2 steps. 2 steps get to 2. 2 steps get to 2. And then it's a decision, right? With 2 steps we can get to 2, and remember, currently our copy is on 1, right? So to 3 is plus 1. Okay. How about 5? Well, we'll take 4 steps to get to 4, right? 4 steps to get to 4, and the copy current is 2. That is not going to work, because 5 is equal to 4 plus 1, right? Or 2 plus 3. Now, when we get to 4, our fastest way to get to 4 will have the copy be on 2, and we cannot reach 5. So to reach 5, we have to do 2 and 3, which means we get 2 steps to 2, which we have 1, and then we need to do 3, right? And do 3 starting from 1 is 3 steps. So add together 5 steps. So are you telling me 5 is going to be 5 steps? 2 steps to 2 and 3 steps to 3. 5 steps. Okay. So I think what we have is, if we have a destination value, right? We have a destination value and the current copy value. Okay? So a destination, not destination. So let's say we want to get to a certain value, right? We want to get to 1. Okay? So I say we want to get to 1, and it's starting from 1, then that's a 0. If starting from 2, well, it's not going to be happening. So if I want to get to 2, we're starting from 1, right? How do we do? We're starting from 1, we just copy and paste on these 2, right? If we start with, not to start with 2, if the current is starting in the copy in the cut board, right? What's that called? Copy board is 2, then it's going to be 0. So diagonal is all going to be 0. So we start with 3, want to get to 3, right? So okay, so we start from 1, want to get to 3. And we have, so 3 we can divide with 3, we can say 1 plus 2 equals 3, right? Or do we do 2 plus 1 as well? If we do 1 plus 2, so we say we want to, so in the start, so we start with 1, right? And then if we do 1 plus 2, and I say 1, when I get to 1, that's a 0. And afterwards, we are, we needed like an afterward value. The last paste. Let's say the after value is 1, then we need to say we start from 1, get to 2 is 2, then we have 3, right? How about we say 2 plus 1? Is that possible? 2 plus 1. Well, if it's 2 plus 1, we say from 1 to get to 2, we need 2 steps. And then once we get to 2, we still have 1, and then 1, we need to get another 1. Wait, hold on. Copy 1, and then we paste, so we have 2 steps. And copy current is 1. And then we need to create another 1, right? We need to create another 1. If I have 1, no, these should be 1. If I have in a copy, right? If I have in the copy is 1, and I want 1, that needs to paste, and that's 1 step, right? 1 step. And the example 2 is a special case where we have target is 1, so already 1, so we don't have to do anything. But these should be 1. So 2, 1 will also work. Okay, so we start from 1 and be 3. What if we just start with 2? If we start with 2, if if we start with 2 and 2 to 1 is nothing, right? So again, we have 1 plus 2 or 2 plus 1, and we start with 2. So start with 2 to get 1 is impossible, right? It's impossible, so we don't consider this. So start with 2 to get a 2. We have one step, and start with 2 to get a 1. That is not possible, so this is not possible. So it's not possible. Let's just say it's minus 1, okay? So minus 1, minus 1, minus 1. Let's do 0. We're going to do 0. Everything is 0. I mean, it's not possible. Nah, I like minus 1. Do minus 1. Minus 1 is impossible, okay? All right, so 4. Okay, 4. So we start from 1 to get a 4. Now we have 1 plus 3, 2 plus 2, right? 3 plus 1. Yeah, okay. So I want to do 1 plus 3. How do we do 1 plus 3? So we say 1 to get a 1, we need 1 step. And then from 1 to get a 3, we need 3 steps. So that's give us 4 steps. 2 plus 2. So 1 to 2. So 1 to 2. We need to record 2 values actually. 1 to 2, and like the end, right? The end is what? So 1 to 2 is going to be 2 steps, right? And now we are stuck at 1, right? Stuck at 1. So next 2 is also 1 to 2 plus 2 is also 4, okay? 3 plus 1. So we need to do from 1 to 3 requires 3. And after 1 to 3, we stuck at 1. So these are all 1, right? After doing that, there's 3. It's all 1. Those are just minus 1, okay? So 1 to 3 is still 1, and then we have 1 to 1 is 4. So these are also 4. So this one is going to be 4, right? But what is the... Wait, hold on. What is the end for this? It could be different. It could be different. Like you can get to 4 from different ways. We can do 1, 1, 1, 1. That's 4. We just... Oh, hold on. You copy 1 and then paste 1. Hold on. You have to copy. So there's always one step. There's always initial step. So copy 1, paste 1. So there's actually 2. But then that takes 5, right? And this one takes 3. Copy 1, paste 1, paste 1. Oh, then we get 2. Is that unique? The minimum number of operations, and with the remaining... I shall think so. Let's consider this unique. Hold up. I need to redo this because I did it wrong. So 1, 2, 3, 4, right? This is starting at 1, 2, 3, 4. So we're starting at 1. This will already have one step we have to copy, right? So if we copy at 1, Hold on. What does it mean? Do we count the copy or not? Like once we add something to a value, right? I add, I copy, and I paste, and I copy again, right? And I copy again, copy the new value. If I copy a certain value, hold up. Let's think about it again. The minimum, the best, right? The best we can reach a certain value, and we also have its current, like in the board, in the copy board. Okay. So now from here, I can decide to reach to obtain the remaining. How do we obtain the remaining? We can either copy it. I have that value to reach the remaining. Well, then the only time that it will work, the only time that if you copy it, it will work is when you copy, and then you need to say, starting from this, what's the minimum I can do, right? So hold on. So this one still, it is right. So like this one, what it says is, using this. Okay, starting from here. Starting from here, what is the minimum number of operations to reach a certain value? Starting from a certain value in the copy board. Okay, so if we start from a certain value in the copy board, and I have, this is the total that we want, okay, then what we can say is I can we start from here. So what I can do, I can paste, right? Hold on. We start from here. If I paste, yeah, I have to paste because there's no other way. So I can paste, right? And then basically I double my current value, right? I double my current value. It depends. It could be from a different value. Because it also has something to do with the previous value. All right, how about this? If it's a even value, if it's a power of 2, we can always divide 2, divide 2, divide by 2, right? If it's the odd value, we cannot divide by 2. It's not possible, right? So we need to what, minus 1? Okay, -1, we can say that's like the first step. And -1, it becomes 2, right? And then it becomes, okay, so I can minus -1. We just keep minusing until we hit a power of 2, and then we do the power of 2 on this. Basically, we just increment until the remaining is power of 2. Does that make sense? Does that make sense? It doesn't feel like, no, I don't think so. Because what if I mean, 256, right? 256, we can actually try. 256 is going to be, I don't know how many times, 2 to the that's 8, right? 2 to the 8. 2 to the 8. So 18 times? No, 16 times. Yeah, so I say this is probably 16 times. Okay. So how about some value? The next one is 1024, right? But we see 1023. It's not gonna be like 200 something. That's not right. Oh, shoot. 1000. Okay. So are you telling me it's gonna be 1000 minus? So 1000 minus 256, 744. So we do 744 steps and then plus 16. That is not right. Doesn't feel right to me. Nah, that's not right. So no. But I do think the goal shall be to reach, power of 2. So we do the minimum amount to reach power of 2. Let me think. It doesn't really have to be power of 2. It could be like, say, power of 3, right? Like if we say 1000, okay? 1000, I say I want to be 500. Okay, I'll keep divided by 2. 250. So 125. We get on to 125. So we say if we can get to 125, okay? If we can get to 125, if we can do 125, then we just copy and paste. That will give us 250, so it's 2 steps. And then copy and paste give us 500. Copy and paste give us 1000. So when we start from 125, we only need 6 more steps. So now the question, how many steps we need to get to 125, right? Now to get to 125, now 125 we cannot. Let's say yeah, this is it from 125. If we start from 125 to 1000, we have straightforward, right? So now we want to say from 1 to 125. Yeah, that's what I think. We can divide this value in half. Alright, so 1 to a certain value, and then from certain value to another value. But then we have different starting values. So when you have different starting value to reach a value, and we also need to know what is the value when we reach this value, right? And the thing is, might have multiple that will have the same value. Whew. It seems complicated, huh? Alright, so we start from 1. So we don't do the copy. Right? We just say we start from 1 to reach 1. Right? We start from 1 and then we want to get 1 that requires 1 step. Right? All the other, and then after 1 step we have 1 remaining. Okay? If we start at 1, we want to get to 2, right? And we say 2 is equal to 1 plus 1, right? So to do that, I need to have start from 1 to get to 1. That's 1 step. And then we have current copyboard is 1, and from 1 to 1 is 1 step. So that's require 2 steps, and with the remaining 1, right? And then if I start from 2, right? Start from 2, how many steps I need? I just need 1 step, and then remaining is 2. Okay? So now for 3, we have 1 plus 2, or 2 plus 1, right? So if 1 plus 2, so from 1 to 1, we need 1 step, and our current is still 1, right? So we don't have to do another copy. And now we want to do from 1 to 2. So from 1 to 2, we have 2 steps. So this one will give us 3 steps, remaining is 1. Not remaining, the copyboard is 1. If we do 2 plus 1, so we first do 1 to 2. In 1 to 2, we have 2 steps, where the copyboard is 1. And this copyboard doesn't change yet, right? And then we just say, oh, now we have a choice, right? We can either copy or we use, yeah, so we just say, because we want to get to 1, we can either go 2 to 1 or 1 to 1. Now 2 cannot go to 1, right? 2 cannot go to 1. So it has to be 1 to 1 that's going to 1. That's those 3. So the 3 is going to be 3, 1. Okay, so what if we start from 2? If I start from 2, I want to go to 3, right? Then it has to be 2 plus 1, right? It has to be 2 plus 1 because it cannot be another way. So if it's 2 plus 1, and then we need to go 2 to 2, right? If we start from 2 and with 2, we need have 1 step, and a current copyboard is 2, and then the other is also 2, right? So we say 2 want to go to 1, no go. 2 go to 1, no go. So from 2 to 3 is actually no go, right? So this one is a no go. 3 to 3 we can go. We say it's 1 step, and then remaining is 3. Okay. So now 4. So 4 we have 1 plus 3, 2 plus 2, and 3 plus 1. So 1 plus 3 we say we do 1, and remaining is 1, and they're the same. So we start from 1, we're gonna go to 3. Start 1, go to 3, we need 3 steps. So that gives us 4 step, right? With n value is 1. Okay, 4 step with n value is 1. Okay, now 2 and 2. So 2 and 2, I can start from 2, right? Start. No, 2 and 2 is, we can say 1 to 2, right? Or we can do 2 to 2. Okay, so for 2 and 2, so for 2 and 2, so we can say 1 to 2, 1 to 2, we require 2 steps, and we end with 1, and then we can choose. Now this is the choose. Now this is the choice, right? So 1 to 2, we all get 1 step, and the current board is 1, and the current value is 2. So we can choose. We either do 1 again, do another 2, so then we have 4 and 1, 4 steps with and 1, or we can choose to do copy 2, right? So if we copy 2, that's an extra step. Right? And then, so we copy 2, that is an extra step. And then we copy 2. Now we find from 2 to 2. And from 2 to 2 is 1 step. Right? 1 step. So we end up with 4 step and end with 2. That's not right. I think it's because the copy is already considered. I say I start at 1, I want to get to 1. It's supposed to be 0, but I say the 1 is already copied. Right? So we already have a copy of 1. So that, let's say, just 1 step, right? Okay, so now we have 4, and basically we say we can get to 1 or we can get to 2. Or both. Okay. Now we have 3 and 1, right? Oh, and then 2 and 2, actually we can start with 2. If we start with 2, we want to get to 2. Oh, well, how do you start with 2? You can't. You have to start with 1. That's why we always just start with 1. Now 3 and 1, we start from 1 to 3, that's 3 steps, and end with 1, and then 1 to 1, and then require 1 step. Right? Require 1 step. So that's also 4 and 1, so that's 4. Alright, how about we start with 2? We start with 2 to try to go to 4. Okay, we don't really care. So we start with 2, we try to go to 4. We need that. Right? We start with 2 and try to go to 4. So we can do 2 plus 2 or 3 plus 1. So with 2 plus 2, start with 2. So we have 1 step ending with 2, right? And then we have another 2. And current is 2. So that's another 1 step. So it's actually 2 steps, right? 2 steps. We ending with 2. Okay, if we start with 2. But of course, if we start with 2, we need to get to 2 first. And to get to 2, we start from 1. To get to 2, require 2 steps. Oh, but start from 1 to get to 2. So I need to copy. And then from 2 to 2. So now I know from 2 to 4, right? And then we can do from 3. We can start from 3, right? We can start from 3. It has to be 3 plus 1. So we start from 3. If we want to go 3, so we're going to go 3 to 3. And 3 to 3 is 1, right? And then we end with 3. But 3 to 1 is empty. So this is empty. Cannot do. So am I just doing this, keep building this up until we reach? Let's do one more, right? Let's do one more. Let's do 5. Okay. Go from 1 to 5. Okay, so 1 to 5 we need 1 plus 4, 2 plus 3, 3 plus 2, and 4 plus 1. Okay. So 1 to 1 is going to be 1, 1, and we have 1, then we need a 1 to 4. And 1 to 4, we need 4 steps, right? And then we end with 1 or end with 2. So for 5, 1 plus 4 is 5 steps. Okay, end with 1 or 2. Okay. 2 to 3, 2 plus 3. So 1 to 2. 1 to 2, we have 2 steps ending with 1. And then 1 to 3 is 3 steps ending with 1. So add together is 5 steps ending with 1. We have that already. 3 to 2. So 1 to 3, so that's the same thing. 4 to 1. So 1 to 4. 1 to 4, we can do 4 steps and ending with 1 or 2. And then we select 1, get a 1, we select 2 is no go. So that's also 5 steps or 1, okay? So we've done that. It's going to be 5 steps. I think 5 is 5 steps, right? Yeah, so it's 5 steps resulting in 1 or 2. No, we start with 2, so it'll be just 2 to 3, 3 to 2. So start with 2. 2 to 2 is 1 step ending with 2, and 2 to 3 is no go, so that's not good. Okay, so 2 to 3. So starting with 2, we want to go to 3. That's no go. Starting with a 2, we want to go to 4. That's 2 and 2, but now we want to go to 1. That's no go. So start with 2 is no go. Start with 3. Okay. 3 to 3 is 1. We start with 3. That's no go. Yeah, if you think about it, maybe we don't have to do all this, because we start with that. So I think once one of them is no-go, then it is no-go. So 1 is go, so we'll check 2, and 2 is no-go, right? If 2 is no-go, 3. Oh yeah, so we don't have to check. We don't have to check when it's above, right? When it's above, we don't have to check because it's just not happening. Because if we start from a value, and we get to this value, it will definitely, it ends with that value, right? So it ends with that value, and the next one is smaller than you, then that's a no-go. So we cannot do, right? We cannot do. So all of these are no-go. So once it's above, then it's a no-go. And of course, start with 4, we cannot get a 5, right? Because start with 4, you can only get a 4, right? And that we end up with 4, and 4 cannot go to 1, so that's also no go. So, but we do have to say start with 5, we can go to 5, right? Okay. How about 6? So we say for 6 we do start from 1, and then we have 1 plus 5, 2 plus 3, 3 plus 2 plus 4, 3 plus 3. And for 1, we might need to keep going, like 4 plus, I don't know, 4 plus 2, 5 plus 1. 1 plus 5, right? So it's going to be 1 to 1, that's 1, and a 1 to 5, that's 5. So it's 6 steps, ending with 1 or 2. Okay? Alright, so 1 to 2. 1 to 2 give us 2, 1. Okay? And then it's 1. So 1 to 4. 1 to 4 give us, so that's also 6 steps in a 1 and 2. Oh, hold on. No. So 1 to 2, ending up we have 2 steps with the current copy is 1, and with the current value is 2. So I can choose 1. Then we need to do 1 to 4, which give us another 4 steps, and ending with a 1 or 2. So this one leads us to 6 steps in a 1 and 2. But there's a second option, which will start with 2. Then we do a copy, so we plus 1 do a copy, then we do from 2 to 4, right? And then from 2 to 4, we have found out is 2 steps, right? So it's 2 steps ending with 2. So added together, we have 2 steps plus 1 plus 2. That's actually 5. So actually this one is 5 steps ending with 2. 3 to 3. So we can do 1 to 3, requires 3 steps ending with 1. And if we do another 1 to 3, so that's 6 steps ending with 1. Or we have 3, so we copy 3, right? And then we from 3 step, 3 to 3. And 3 to 3 is 1 step ending with 3. So this one is 3 steps, right? Plus 1 plus 1. That's 5 steps. 5 steps. And then we'll end at 3. 5 steps and a 3. 4 and 2. Okay, 4 and 2. So we're gonna go 1 to 4, so with 4 steps, we end it with a 1 or 2. So I can copy 4. Well, that's no good. Copy 1 will require 2 steps. Copy 2. 2 to 2 require 1 step. So that's 5 and 2 as well. 5, 1. 1 to 5. That's 5. So that's going to be 6 and 1. So overall, it's going to be 5, right? 6 is going to be 5 steps, ending with 2 or 3. It's kind of convoluted. Then we have to check start from 2, and then check start from 3. And we start from 2, we're going to check, say, 2 plus 4. Okay, I'm going to try. I mean, the thing that stand out is around 1,000. So it's very likely that it is a brute force, kind of brute force solution, but you just need to figure out how to brute force it, right? So we're gonna have a DP table. Let's call it Damn. N plus 1. And then I make this. Alright. That's a row. A row, And then for this in range n plus 1. Now these are the columns. And then we're gonna set, let's say dp 1 1. Right, dp 1 1 shall equal to 1 1. Of course, if n is equal to 1, return 0. dp 1 1. That's done. Alright, now what we're going to do is for I in range 2 to n plus 1, right? We have to go all the way to the last one. And then for j in range, it's going to be for j in range from 1 all the way to I divided by 2 plus 1, right? Because it's not going to be larger than that, right? And one more thing. Actually, we can do this for k in range 1 to n plus 1 dpk k equals k. One step of this, okay? Okay, now for each one, okay? For each ij, because it's j, right? And then we're gonna have, oh my god. My god. So for each it's called temp, is this. Okay, so j is a starting point. Then this value can be divided, right? And what's the current value? I is the current value. Okay, I is the current value. Then for p in range j to I minus j. Okay. So now I'm examining, we start from j, right? And then we can say p, wait, hold on. What I'm doing here, I'm trying to say j plus something, and then j plus 1 plus something, j plus 2 plus something, so all the way down. So now, so p shall be, so p and j all the way to J is a starting point. Okay, J is a starting point. So P is the first value. Now this is actually to I. Well, I'm I to I. To I. Okay. So this is going to be to I. Okay. So now we have two values. We have Q. Let's say Q equal to I minus P. Okay. Now it's P plus Q. So we need to find out from J to P, right? From J to P, what is the minimum steps? Okay. So minimum steps. Oh my God. So every one we have a temp. I have another temp. Let's move this temp here. Okay. And then we say step to P, right, shall equal to step to P shall equal to dp, which goes from J to P. Okay. And then that's the first step, right? That's the first step. I have it. I have it. So we have this, and then we say if, right? If step P, because sometimes it doesn't work. So if step P, then what? So we have step P, right? And then within step P, I know the step, and I need to know the next step, right? The next step can be for C in step P1, right? And then we can call it dp from C to Q, right? C to Q. And then what we can do is I need to find out the smallest of all these, right? The smallest of all these. And then we say, I don't know, smallest of all these. I say min steps. Okay, so min step, let's say equals math.inf. Okay, that's the min step. And then we check all those steps, right? Each step, we're gonna say min step. An end copy, right? End copy. It's going to be a this. And then we say, that's for C, copy, right? Copy in this. And then this one will give me a copy, and we can call it step Q, okay? So step Q is this thing, right? And then we say, if step Q 0 is smaller than min steps, then min steps equals step Q, no, it's Q, steps Q0 and copy equals step Q1. We can just say min step and end copy, right? So if it's this, if step Q0 is equal to min steps, right? And then we say end copy dot append step Q1, right? What else? If it's larger, then we just don't worry about it. And then once we're done, one more check, right? One more check. Check for what? Check for the current, which is P, right? We get to P. So we can do P. And we say if dp from P to Q, if this one exists, right? If this one exists, and we say if this one exists and min steps and 1 plus dp p q 0, right? If this is smaller than min steps, then min steps and copy shall equal to this thing, okay, this thing, and end copy is going to be dp p q 1, right? So we do all that. After we finish all that, so we have obtained min steps, right? So we're gonna update temp, right? On update temp. We say if not temp equals min steps and copy, right? Else aleph what? Aleph temp 0 is min step, right? Min steps is smaller than temp 0. So if not, we can just do math.inf and it doesn't matter. So we say if this, right? Aleph min steps equal to temp 0, okay? Then temp 1 plus equal to and copy plus equal to. You might want to make them make that a set. Like, set can plus, right? Yeah, this most likely is not right. It's the none of the problem is that complicated. Yeah, A dot union B. Yeah, it has to be a set. The current way I'm doing it. Okay. Are we done? What do we do when we're done? Well, we say if temp 0 is still equal to mass.inf, then dp. Now we don't update, right? So if it's smaller then we say dp. Wow, it look great. So dpij, we update dpij equal to temp. And then we're done. Now when we return dp n and 1 and 0. I'm just gonna try it. If it didn't work, I'm gonna give up for today. I'll try it again tomorrow. I have all these test cases. Come on. I have all these test cases. Okay, I have 4. I know the 4. No, 2 is 2. No, 8 is 6. 16 is 8, right? 16 is 8. 32 is 10. 5 is 5. Who's 16? 256. 16. 1000. 1000 is 21. Actually, when we have 1000, we can get all of the results for the test case. Just realized that. Yeah, we're able to get all. Okay, let's just try these. Min steps is not defined. Well, of course it's not defined because it's underscore. Oh my god. Underscore. Index out of range. Yeah, it has to be if step Q. Then we do this. Index out of range again. Ooh, what the hell? Print DP. Take a look how it looks like. That's not the best way. Huh. Alright, this is not right. That shall be 2, 1. Okay, I equals 2, j equals 1. So p gonna be 1 to 2, 1. So it'll be 1, and that also be 1. Oh, I forgot to add something. Step. Blah. If min steps. Alright, so the min steps is from step P, right? So this shall be min steps plus step P 0, right? And then min steps. So these has to be more specific. These are min steps min step Q, right? And then after this, let's say MS as min step. So we put the min steps Q plus step P 0. And these are MS. Okay, so we still have some issues. Okay, so that would be 3. 3 divided by 2, so it would be 2. It would be 1, right? This is the end of step P, okay? Let's see, J, P, and then step P. So 1, step P is 1. Okay, 1 to 1. What's Q? Let's do Q as well. Okay, so Q is 2. And then Q is 2. And then we say DVC, so it's 1. Right? C is instead, so C is 1, 1, so 0, 1. Oh, I think this shall be, the target is Q. Wait, hold on. What is row? Row is row is the target. Column is what we start with. Okay. Yeah, it's fine. Yeah, it's just oxidized. Still good. So this just has to be, the target is Q. We'll start with C. Okay. And I think I have another one. DP, where are the other DPs? So DP, this shall be, you end with Q, start with P. All of these need to change. Alright, so this has to be DP, Q, and P. Okay, yeah, this is what I was looking for. Oh my gosh. Seriously? The hell? Which one? Which one failed? Oh. Oh. It didn't fail, it just took a long time. Man, this is gonna time out, man. Because I'm checking so many different possibilities. Huh. You know what? I'm gonna end it right here. Yeah, this one's tough. Yeah, I'll try it again tomorrow. Yeah, this is not working. This is not working. Wow, we got 2 questions in a row and I won't not able to solve immediately. Alright, see you guys tomorrow. Adios.